Hi guys, welcome to the Unit 1 remediation practice video. I'll be doing two videos here, so this will be for part 1. We're going to start with identifying our significant figures. Remember, the rules are that any number that is not 0 counts as a significant figure. Numbers that are sandwiched, zeros that are sandwiched between numbers that are not 0 count as being significant. Numbers that are leading or in the front of a number are never significant, and numbers at the end of a number are only significant if there is a decimal in the number, and it's important to note that it does not matter where that decimal is. So if there is a decimal in the number, then zeros at the end are significant. So here's a couple examples. This example number 1, there are no zeros in this number, which means we just count the non-zero digits. So this number would have 1, 2, 3, 4, 5 sig figs. 5 sig figs. Here we have a couple instances of sandwiched zeros. So all of these digits that are not 0 count. So it looks like there's 4, 5, 6, 7. Plus, these zeros are sandwiched in between non-zero numbers, so those count as well. So we had 7 numbers that were not 0, plus these other zeros, so that's 8, 9, 10, 11, which means this number has 11 sig figs. Example number 3. These first 3 digits count, but these zeros at the end are trailing, and there is no decimal in this number, so they do not count. They are simply placeholder zeros, so this one only has 3 sig figs. And in the last example, number 4, these zeros are leading zeros, so they never count. These are trailing zeros, and they only count if there is a decimal, which there is a decimal in this number. So this guy has 1, 2, 3, 4, 5 sig figs. So that is how you identify the number of sig figs in your number. But what do you do with that? We oftentimes have to do math and use our significant figures to apply to our math problem. So there's two scenarios. There's the adding and subtracting rule that says you have to round your answer to the last common place value of the original numbers in the problem. And then there's our multiplying and dividing rule, which says we round our answer to the lowest number of significant figures as the numbers in the original problem. So if we have this example, 6.3 plus 8.12 plus 0.213 plus 18.0, and we add all of those things together, we get an answer of 32.633. But this was addition, so we have to double check and round off our answer to a certain number of significant figures. And so the rule for adding says we round to the last common place value of all of our original digits. So if I look at this first number, this 6.3 has a number in the ones place and the tenths place. This next number has a number in the ones, the tenths, and the hundredths place. This next number has a number in the tenths, hundredths, and thousandths place. And then the last one has a number in the tens and the ones place. So the only place value where these guys have something in common, or the last place value where they have something in common, appears to be in the, in the tenths place. They all have a number in the tenths place, and that 0 is important. It wouldn't be there if it wasn't, because remember, zeros at the end of a number count if there is a decimal. And there is a decimal, so that 0 is important. So since we said this has the common place value is all in the tenths place, that's where our answer has to round off to be. So we check the 10th place. We look at the next digit over to see if it needs to round up or stay the same. 3 is not large enough to make 6 go up, so we call our answer to the correct number of sig figs 32.6. Now for this next one, we got 5.6 divided by 2. And so when we just type that in the calculator, it comes out to be 2.8. But since this was division, we have to pay attention to the rule that says we round our answer to the lowest number of significant figures as the numbers in our original problem. This first number has 2 sig figs. The number 2 only has 1 sig fig, which means we need to round this answer to only 1 sig fig. So we're going to round off here, but you still have to check the next digit over to see if it makes it round up or stay the same. 8 does make this number round up, so we would call our answer 3. So molar mass is the next thing. For the molar masses, you simply add up the molar mass or the mass from the periodic table for all the elements and just make sure that you multiply by the correct number depending on what the subscript is. So if I look at the periodic table for magnesium, I see that magnesium has a molar mass of 23.405. There's only one magnesium, so I multiply that by 1, which is the same number. And then for chlorine, it has a molar mass of 35.453, but there's 2 of them, so I'll multiply that by 2 to get 70.09 or thereabouts. And so now I got to take my magnesium mass and my chlorine masses and add them together, which gives us 94.311 grams per mole. So I'm going to skip this one. You can try that one on your own, but let's look at this one where we have parentheses present. So here we've got 2 aluminums, and so the mass of aluminum on the periodic table is 26.98. So we'll do 2 times 26.98. And then for the sulfate, it's in the parentheses, so the subscript on the outside of the parentheses multiplies in for that sulfur. So we have 3 times the mass of sulfur, which is 32.066. And then this oxygen has a 4 on the inside of the parentheses and a 3 on the outside, and the 3 multiplies in. So we have 12 oxygens at 15.999. So I trust that you guys can do that multiplication, and of course we would add all of those values up at the end. If you're struggling with that, then you really should come in for tutoring. And then the last thing I want to cover in this first video is percent composition. So for percent composition, remember you always think in terms of part over whole times 100. That's how you find percentage. So the first thing you always have to do is to find the total mass of the compound. Well, we started to do that and we didn't finish it up here. I didn't finish it up here, but I'm going to go ahead and do that real quick because we need the total mass of this compound, this Al2SO4 with a 3 on the outside of the parentheses. And so I get that the total molar mass of this guy is 342.146, and that's going to be in grams per mole. And so now what you do, if I want to know what percent of that mass does aluminum contribute, so you take the mass that aluminum contributes, or the mass of just the aluminums, which from up here was 53.96, you put it over the total mass and multiply by 100. So 53.96 divided by 342.146 times 100 gives us 15.77%. So that is the percent composition of aluminum. Do the same thing for the sulfur. There were 3 sulfurs at 32.066 grams per mole each. So I get 96.198 over the total mass times 100. Tells me that I got 28.12% coming from the sulfur. And then the oxygen, there were 12 of those at 15.999 apiece, so that was 191.988 grams for every 1 mole of that component times 100. So I got 56.11%. And a way you could quickly double check to make sure that you've done that right is that percentage always means out of 100, so these percentages should add up to really close to 100%. Rounding will cause a little bit of discrepancy, but 99%, 99.99% is pretty close to 100, and that's what you're looking for. Thanks, guys. See you for the second video.